Welcome to the Dragon 9 Media Podcast. This podcast is the fifth in a series focused on learning about artificial intelligence. If you enjoy this content, please subscribe and like this channel to help promote it to others. Hey everyone, and welcome to AI Demystified. Today we're diving into one of the most exciting and powerful parts of artificial intelligence, something called deep learning. You might have heard the term, maybe it sounds a bit intimidating, but I promise, by the end of this, you'll get what it's all about and see how it's already changing the world around you. So, to get to deep learning, let's quickly zoom out. Artificial intelligence, or AI, is the big umbrella term for creating computer systems that can do tasks that usually require human intelligence, like learning, problem-solving, and decision-making. Think of it like teaching a computer to think, in a way. Now, under that AI umbrella, we have machine learning. This is where we get computers to learn from data without being explicitly programmed for every single step. Instead of writing a million rules, we show the computer a ton of examples, and it figures out the patterns itself. Imagine teaching a child to recognize a cat by showing them lots of pictures of different cats, rather than describing every possible feature of a cat. And that brings us to the star of today's show, deep learning. Deep learning is a type of machine learning that's especially good at finding really complex patterns in huge amounts of data. It uses something called artificial neural networks, or ANNs. And the deep part? It just means these neural networks have lots of layers. Why layers? Think of it like a super efficient sorting office. The first layer might sort the raw data by very simple features, like basic shapes or colors in an image. Then, that sorted information goes to the next layer, which looks for slightly more complex patterns, like, does this combination of shapes look like an eye or a nose? Each layer builds on the previous one, looking for more and more sophisticated features until the final layer can make a decision, like, yes, that's a cat, or this sentence sounds positive. This ability to automatically learn relevant features from raw data through these layers is what makes deep learning so powerful. So, how do these deep learning models actually learn? It's all about the data. They often start with what's called a foundation model, which is a large deep learning model that has been pre-trained on absolutely massive amounts of general data. We're talking terabytes, even petabytes. This pre-training helps it learn general patterns, like how language is structured or what common objects look like. Then, this model can be fine-tuned on more specific data to get really good at a particular task. Imagine learning to read. First, you learn the alphabet. That's like the basic understanding. Then you learn to form words and basic sentences. That's the pre-training on general language. Then, if you want to become a medical expert, you fine-tune your reading by studying lots of medical textbooks. A deep learning model, learning to diagnose diseases from X-rays, would be similar. It might start with a general image understanding model and then be fine-tuned on thousands of medical scans. One of the coolest things about deep learning, especially with these multi-layered neural networks, is that they can automatically figure out what features are important in the data. Early AI often needed humans to painstakingly tell the system what to look for. Deep learning models, especially the deep ones, kind of do that on their own by passing data through those layers of analysis we talked about. This has led to huge breakthroughs in things like understanding images, speech, and text. Let's look at some specific types of deep learning networks you might hear about. Convolutional neural networks, CNNs. These are superstars for image and video processing. Think of them as having special filters that scan over an image, looking for patterns like edges, textures, and then more complex shapes. This is what powers facial recognition on your phone, or helps a self-driving car identify a pedestrian or a stop sign. Recurrent neural networks, RNNs, and transformers. These are brilliant for sequential data where the order matters, like text or speech. They have a way of remembering previous parts of the sequence to understand the context. Transformers are a more advanced type and are the backbone of many amazing language models today, like ChatGPT or Google's Gemini. They can translate languages, write articles, or even help you brainstorm ideas. And this leads us to generative AI, which you've probably seen a lot of lately. Many generative AI systems, which can create new text, images, audio, or even code, are powered by these deep learning foundation models. For example, you can give a text prompt to a model like DALL-E, and it will generate a unique image based on your description, or a model like Gemini might take a photo of cookies and generate a recipe for you. The impact of deep learning is already huge and growing. In healthcare, it's helping to analyze medical images like X-rays and MRIs to detect diseases like cancer earlier and more accurately. In finance, it's used for things like detecting fraudulent transactions almost instantly. You use it every day in recommendation systems on Netflix or Amazon that suggest what you might like next, or when you talk to voice assistants like Siri or Alexa. Now, deep learning is amazing, but it's not magic. There are some important things to keep in mind. It needs a lot of data. These models learn from examples, so the more high-quality data they have, the better they generally perform. It needs serious computing power. Training these big, deep networks takes a lot of processing power, often using specialized hardware like GPUs. The black box problem. Sometimes, even though a deep learning model is very accurate, it can be hard to understand exactly how it arrived at a specific decision. This is a big area of research called explainable AI. Bias is a risk. If the data used to train a model contains biases, like underrepresenting certain groups of people, the model can learn and even amplify those biases. This is a super important ethical consideration. So that's a whirlwind tour of deep learning. It's a field that has truly revolutionized what AI can do by enabling machines to learn complex patterns from vast amounts of data using layered artificial neural networks. From the apps on your phone to cutting-edge scientific research, deep learning is a driving force of innovation. It's a constantly evolving area, with researchers working to make it even more powerful, efficient, and understandable. Thanks for joining me on AI Demystified. I hope this has helped you understand deep learning a little better. Join us next time as we continue to explore the fascinating world of artificial intelligence. Thank you for watching. If you enjoyed this content, please subscribe and click the like button to help promote it to others. Our plan is to create many different learning tracks, with podcasts, articles, and other supporting materials to support your learning journey.